So I'm Brian Brousseau from Dockside Electronics in Mystic. We do pretty much anything electronics on boats. I think this is probably the 5th or 6th year I've done this seminar here. This is the U.S. Power Squadron. So it's kind of hard to tell on the slide, but this line here is a dotted line. That is what we call an EBL, electronic bearing line. And the other line I told you to ignore is this circle right here. That's a variable range marker. So those are tools that we can use, which we'll talk about in a little more detail, to help fix our position and kind of get an understanding how a collision situation might be going to play out. So radar is an active system. It transmits radio frequency pulses, and this is both with solid state or a traditional magnetron radar. It's got a receiver in it that receives that transmitted pulse after it gets reflected off of a target. And it measures the distance to that target, and it does that by measuring the time. So it's, I think, 12.5 microseconds for the radar pulse to leave your radar, go out, hit a target 1 mile away, and then come back and get received again. So by measuring that time, it ends up with the distance. And then we also measure the angle of the antenna, and that gives us the bearing. So some things that we'd get reflections off of are other ships, buoys, land, any structure that's out there, anything that's pretty prominent from the water. We'll also actually get some echoes off of the water itself, which is what they call sea clutter. Rain, we'll get some reflections from that. And some of these things that we're getting that are showing up on the screen we would call contacts, returns, targets. So we're all talking about the same thing. It's just something that's showing up on the screen. So this is one thing that has changed recently. There's two parts to a radar system, scanner unit and display. We do have those two parts. However, in more modern stuff, more and more stuff is handling actually up inside the antenna. So before we would have a transmitter and receiver inside the antenna, which is what this is here, which I'll show you in a little more detail. But this is a TR unit out of a radar. And then we would have the display, which would take the raw signals out of this and make a picture out of it. Now all that's happening inside the antenna, and we're sending an Ethernet signal down, and we're just using that as a remote display. So it's the radar antennas are no longer as tied to the display as they used to be in the older systems.
And what do you consider older systems? What do you work to break off year?
So it's not really a year, it's really a technology. So today I can still buy a basic Furuno radar, which the TR pack is up above and the display is still processing the video down below. But that's the same technology that's been around since really the 70s.
Well, if you have an older unit, which I suspect I do, of 2000, is there any reason why I should replace it with a new unit if it seems to be working fine?
Not for that reason.
Okay.
No. And actually, there's, like I said, there's still radars that are built that way, but more and more radars are not being built that way. And the one in the slide here, this was kind of like a hybrid of that. So they did more and more processing up in the antenna, but they were still sending analog signals down to the display. The next version, and actually it was compatible with that display, you could do what they call their digital radar, which everything was then up in the antenna. So you know it was, and so that's a 2003, 2004 vintage display right there in the slide, and that would work either with the older analog signals or the newer digital signals. So inside the scanner unit, you definitely always have an antenna, you always have a transmitter, and you have a receiver. The display unit, you've got your operator's controls on it, the physical screen, and the processor where it's processing that video. Again, that's where it's slightly different on the newer systems, because all that processing happens up above. it's kind of a semantical thing, but. So this is kind of a block diagram of what goes on inside here. We've got the transmitter, which they're showing as a magnetron, but that could just easily be a solid-state RF amplifier. The receiver and display unit, and then this is the antenna down here. So the signal leaves the transmitter, you see the line turn red, and goes to the antenna. The signal then exits the antenna and starts going out along towards a sailboat that's out here. This is going to be our target. It then hits the target and is reflected back. And as the signal comes back, it goes back into the antenna, and that signal goes to the receiver. At the same time, we are getting azimuth information, basically what bearing the antenna is on. And that information goes over to the display unit, and the display puts those two items together and generates a picture. So this is a transmitter out of a 30,000 watt S-band radar. I like it because it's big and I can show you the parts of it. This is the magnetron. This is the transmitter tube. It's actually a vacuum tube. And this is what they call the modulator. So this is the part of the board that builds the signal up to send to the transmitter tube. What you can't really see in here, but if you can imagine, there's actually a waveguide that runs up through here. The signal leaves here and comes out this port, and there's a cable that goes up to the antenna. When the signal is received from the antenna, it goes back down to this port and travels its way up through here to the receiver. So this is the microwave receiver right here. And those signals then come over to this side and go into this receiver strip before it's sent down to the display. And these connections here are where the display would connect. So on here would be your bearing, your trigger, and your, what's the other one? Azimuth. And then this would be your video coming out. So all those raw signals would then go down to the display to be seen. So these are two magnetrons. This is the same one that's in this radar here. This is the waveguide. The actual tube is inside here, and this black thing is actually a real powerful magnet. And so the energy is actually, this is a little antenna in here, radiates out this way. So again, this is a 30,000 watt S-band unit. This is what you typically have in a recreational radar. This is probably a 6 or a 12 kW X-band. But in all the small radars, they're about the same size. And you can see this window here is much, much smaller. That's because it is a much higher frequency. Your radars run on 9.8 gigahertz, and that's about the wavelength of that. This is 3 gigahertz. So I'll send one around each way.
You said that's a powerful magnet. That's up in the antenna?
It is. Yep.
And that's up on the mast.
Yep.
Is that normally far enough away from the compass so that there's no magnetic interference?
As a general rule of thumb for basic magnetic fields, we say about 3 feet
Yeah.
to keep things away from the compass. That is really a focus magnet onto that point. So if you put something metal near it, you won't feel a lot of magnetism. If you take that magnet off, you'll really feel it because it's really focusing its stuff into the tube. But I would say if you're 5 feet
probably
away
far
from your
enough away,
compass,
yeah.
you'd be fine. They say radomes are for sailboats and small power boats. Typical radome size is an 18-inch to 24-inch dome. The unit outside is like a 20-inch. And when they say the size, 18, they're talking about the antenna that's inside the dome. So the dome's actually bigger than 18 inches if you took a tape measure to it. But the antenna in the unit outside is like a 20-inch. And they say open arrays are for large power boats. The reason why I have a problem with this is because really in an ideal world would have the biggest antenna we could possibly put on the boat. And a couple reasons for that, and we'll see in some detail later. But the bigger the antenna, the better picture you're going to get, the more performance you're going to get. So to say that you can't have a big open array radar on your sailboat because it's a sailboat is kind of silly, but in reality, it comes down to actual, mounting applications. Also bigger is also more expensive, so that's another factor. But anytime you can go to a bigger antenna, you're going to get a better radar picture out of it.